Hello, 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 everybody, and welcome back to the 2006 Pascal paper. That is the Grade 9 multiple choice contest from the University of Waterloo, and we are on the second last question, question number 24. It's also the second last question in Part C, so it should be the second hardest question on the contest. We'll see if that's true. Alright, so question 24. A bag contains 8 yellow marbles, 7 red marbles, and 5 black marbles. So that's a total of 20 marbles we start with. Without looking in the bag, Igor removes n marbles all at once. I don't quite know what n is. Perhaps I'll be asked to figure that out. If he is to be sure that no matter which choice of n marbles he removes, there are at least 4 marbles of one color and at least 3 marbles of another color in the bag, what is the maximum possible value of n? So they have to be left in the bag, no matter how he chooses. So, this is an interesting, it's a logic-y question. We need to sort of think through it. There's not going to be a whole lot of calculation to this one. But just for example, suppose I made n is equal to 15. It's possible that the choice of marbles he happens to pick out is all 8 yellow marbles and all 7 red marbles. That would leave only 5 black marbles, but we need to have at least 4 of one color and at least 3 marbles of another color. So, what to do? Well, let's take a look at some examples here. Start with 8 yellow, 7 red, and 5 black. Now, suppose n were 3. What could we have? Well, we could take out a red, a yellow, and a black, and that would leave 4 black, 6 red, and 7 yellow. Okay. But we could also take out all 3 of them being black, and that would leave 2 black, 7 red, and 8 yellow. Okay, or we could take out 2 yellows and 1 red. Okay, there's lots of possibilities. In each of these, we can see we have at least 4 of one color and at least 3 of another color left. Now, needing at least at least 4 of one color and at least 3 of another means we must have 7 marbles at least left. So this tells me n can be at most 13. Now, is this what's going to work? Okay, if I take out 13 marbles, is there some way that I can take out 13 marbles that I fail the condition that I need here? And it's certainly possible. For example, if I took out, so if n were 13, what could I do? Now I sort of have to play a game where I'm trying to mess things up. I'm being sort of an antagonist. And often when you write up these things formally as a research mathematician, you'll introduce a character called the antagonist who does the worst possible thing imaginable. So now, as the antagonist here, I have to think, okay, I get to pick 13 marbles out, and I want to make sure that I don't have at least 4 of one color left, or at least 3 of a different color left as well. Okay, so how can I do that? Well, my eyes fall on the 5 black, the 7 red. If I just take those out, I don't even have a second color, period. So I could just be left with 7 yellow. Okay, well that doesn't satisfy my condition. So n can't be 13, and now I've shown n has to be at most 12. We know it's got to be at most 13 because they have to have 7 marbles left. But just being n is 12, well, that's not going to work either. Okay, I could just take out all the reds and all the blacks. I need to have at least 3 of another color left. I only have 1 color. I can't have 2 colors here. So that tells me n's not going to be 12 either, and I've shown n is at most 11. Now, with a question like this, I might look and say, well, gee, let's look at the multiple choice answers. Pretty sure n equals 11 isn't going to work, because at best the answers they're giving me are things like 10. Okay. And another way we can sort of try and shorten our work is look at the possibilities. 6, 7, 8, 9, and 10. Let's try and see, can n equal 8 work? Okay. Now I chose n equals 8 because it's in the middle. Okay. 6, 7, 8, 9, 10. If I can show that n can't be 8, well then it can't be 9, it can't be 10. I've suddenly eliminated 3 of my options just by looking at one example. Okay. And if n could be 8, you know, if no matter how I take 8 marbles out, I'm still left with 4 of one color and 3 of another, then that tells me 6 and 7 aren't going to be the answer, because we're looking for the largest possible value, and I already know that at least 8 would work. Okay, so then I could be eliminating some options as well. All right, so let's take a look for a moment at n equals 8. Okay, so for n equals 8, we'll be left with 12 marbles. Okay, so it seems quite reasonable that we could be left with enough marbles. We start with 8 yellow, 7 red, and 5 black. Well, I want to make sure that, so I want to try and get no black, and I want to sort of get 2 red. That's my goal here. Because that takes the least number of marbles to remove one whole... Actually, you know what? Something like this. 8 yellow, 2 red, and 2 black. This does not satisfy the conditions. Yeah, I've got 4 yellow, but I don't have 3 red, and I don't have 3 black, so I don't have 3 of another color. So that's 8 plus 2 plus 2, and that is left with 12 marbles. So that tells me n can't be equal to 8. And I'm pretty sure the answer is n is equal to 7, because I think this is the best that we can possibly do. This is the most number of marbles I could be left with that does not satisfy the condition. Okay, but just here, knowing that n can't be 8 tells me it can't be 9, it can't be 10, and at that point, I could take a guess if time ran out. Okay, but let's take a look at 7. So n equals 7. We are left with 13 marbles. Okay. So with 13 marbles left, and I want to fail this condition somehow. Okay, to not be left with 4 of one color. So to not satisfy the 4 of one color, we'd need at most 3 of each color left. Therefore, we would need less than or equal to 9 marbles left to make that happen. Well, that's not going to happen with 13 marbles. So the only thing left to do is to make sure we don't satisfy the 3 of another color. That's the rule that we can break quite quickly. Okay, so that means we could have, so 2 of the piles, or 2 of the colors, have at most 2, left? Well, and then we don't care about the third color. Well, the best that we can do is 8 yellow, 2 red, and 2 black. Okay, we could do it with 2 yellow, 2 red, and 5 black, but that would be removing more marbles. And we've got to remove only 7. Well, this is 12 marbles, as we already noted, which is less than or equal to 13. So we will need a 13th marble, and it'll have to be red or black. And so then we'll have 3 of another color left over. So no matter what we do, n equals 7 works. And there we go. Our answer is B. Now, I like these sorts of questions because logic is very much a part of math, but you'll notice I did very little calculation here. N equals 8, we're left with 12 marbles. It's simple subtraction. The real meat of the problem is thinking, okay, how can I screw this up? What possible things can I remove? And you sort of have to think through the problem. And it is logic, it is trains of thought. It is how we break down and analyze the problem rather than squaring or remembering circle theorems and things like that. So I like these types of questions. I find that they pop up from time to time, and it is just a pure thought exercise. Can I think through this? Can I reason this? Can I make myself convinced that this should be the answer and not this number? Okay. So the Pascal question, it wasn't particularly hard to follow through. If you had any trouble with my reasoning, by all means leave a comment, and I or someone else might be able to help you along thinking through it. But there we go, n equals 7, and that gets us all ready for the last question, question 25, which I'll see you for in the next video.